Welcome to the second part of the 3D scripting tutorial. In the first part, you learned how to build your own 3D script from scratch. But if you don't have the time or you don't want to spend tokens generating one, I've created a set of ready to use 3D scripts that you can download and use right away. Now, let me walk you through each script, explain what it does, and show you how to use it in your own projects. All right, so now we are inside, my polished script file, and as you can see, I have all the nodes which we created in our demo script. So I'll just walk you through all of these one by one. So I'll start with um, the model importer. It's called GLTF Viewport 3D. You can change the name, of course. So yeah, as you can see on the property group has all the things which we had in our demo script. So one thing which we couldn't do in our demo was like the textures. So the model importer was not able to import the textures properly. But here in this one, as you can see, we have the textures. You can see this, and down here you can see there's a use texture property as well. So you can turn it off if you don't want it. Now I'll just have a clay style render to it. Okay, so now let's look at the camera control. So I added a click to orbit feature as well, like how you have in the 3D programs. And let's go through the properties now. So we have camera yaw, camera pitch, camera distance. You have camera target. So if you want to change the position of the camera orbit, you can do that. So XYZ is there. We have camera near and camera far. So basically it's the closest and furthest distance the camera can see. So you can change it to see it work. And it's the same thing with the camera far. Yeah, it's working. If you're coming from Cinema 4D, you would know how it works. The aspect is basically the aspect ratio. Not a big fan of this property, but yeah, it's fine. I think it totally destroyed my camera. Next we have camera position, XYZ control. So you can change the camera position, which will allow you to move the camera around the scene. These properties can also be keyframed in animation mode. And the camera is always locked onto the 3D object. So no matter where you move it, it will continue looking at the 3D model, which is super nice. After that, we have orbit speed. Orbit speed controls how quickly the camera rotates around the object when you click and drag. So if you want to increase that, you can set it to, let's say, 2. So now it's moving super fast. Or you can reduce it to 0.2. So now it's gonna move much slower. Next is camera pan control. So when pan mode is enabled, the camera switches from orbiting the object to panning across the scene. So if we increase the pan speed, let's say whatever. So now it's not orbiting, it's kind of panning. So you can do this. And if you want to get back to the orbit mode, you can set it to false, and now it's going to come back to orbit. So just in case if you want it. Next we have reset view. So it'll just return the camera to its default position and orientation when you started. You also have grid properties, so you can turn it off or on. You can also change the scale of the grid. There's an auto spin option, which automatically rotates the camera around the object You can enable or disable it, and adjust the spin speed, um, you know, to control how fast the rotation occurs. Next, you have MSAA, which stands for anti-aliasing. So I don't know if you can see, if you kind of go close to the camera, and if I set it to 0, um, you know, there's a lot of aliasing happening on the edges. uh, as you can see, maybe here you can see this like flickering aliasing, which looks kind of bad. And if you increase it to, let's say, 5 or 6, you know it should get rid of that. Next, we have focal length. So it works like the focal length of a physical camera and the sensor height. So it's a very common property if you're dealing with any kind of digital camera. Next, we have scene width and scene height. So if you reduce you can just set the size of uh, the GPU canvas. So if I set to 500 by 500, and if I play it, it will render the 3D canvas in that particular size. Okay, next we have lighting controls, which let you adjust how the 3D model is illuminated. Starting on the top, light angle controls the direction of the light around the 3D model, while light height moves the light higher or lower. Next, we have key color and intensity control. Um, it's the main light source, which creates the primary highlights and shadow on the model. So you can, change the color, increase or decrease the brightness of it. Below that, we have fill, color, and intensity, which controls the secondary light that helps soften um, the shadow and reveal more details in the darker areas. So you can see, if you change the color as well. And finally, the ambient color and ambient intensity, which controls the overall scene lighting, adding even illumination across the entire model without creating additional shadows. All right, so now let's move on to material controllers. And the first property in material controller is shading mode. So on my left, you can see I have a list of all the shading modes I have created. So I won't go into much detail, but I'll just give you a quick overview of how these shaders work. So we'll start with wireframe. So as you can see, it's more has a wireframe overlay on top of the base model. You can turn off the texture to suit better. One is unlit, so like there's no light affecting the shader. Two is it's very flat and does not have any polygon smoothing. So if I change the light, you can see the edges of the polygons. Three is Gorard shading. So Gorard is basically diffuse plus specular light. So you can see some directional light reflections on it. If you change the angle of the light, you can see these reflections. So it kind of makes it look semi-realistic. Next, we have PBR, which is much realistic than Gorard shading. So if I reduce um, if I increase the intensity, maybe reduce so you can increase the roughness to see the reflection. You can also make it more metallic in this mode, which is not available in other modes. So yeah, you can see. And you can of course like change the intensity of the key light to control the lights. So you can like experiment with like roughness and metallic properties to make it more realistic. Moving on, we have a clay render. So it's a combination of diffuse, ambient, and AO shaders. So there's no reflection on it. So it's pretty simple. Just looks like clay. Next, we have the Toon shader. So this is my favorite. So if you've used Cinema 4D's Sketch and Toon shader, it works pretty much. It looks very similar. So basically, Toon Shader gives your artwork a flat cartoon style look with bold highlights and shadows. Like you can see here, like you can see the distribution of the highlight and shadow here. So you can see like the highlight and shadows are not smooth. It's kind of like really flat, and you can see the distribution line, and you can like change the colors to like make it more uh, cartoon like. Okay, now let's look at one extra feature I added to the material controller is UV projection. What UV projection does is basically take a component. So let's take this one, and you can animate anything inside it, and you can use that uh, to project it on top of the 3D model using UV projector. So let's turn it on. So as you can see, if I play this, you can see that animation is projecting on top of the model. So you can, change the rotation of it to whatever angle you want. You can change the projection mode. So, it'll project in a different direction. So now this is going uh, towards the left. This is going from bottom to up. This one looks more like circular or radial projection. And then you have and then you have properties to control the emissiveness. So you can turn off the emissiveness, and it can just like project the flat texture. You can change the emissive intensity, or you can change the opacity of it. So it kind of does the same thing. And also you have UV tiling option. So if you want to change the tiling, you can do that too. So you can like really make some cool stuff with it. So you can keep experimenting with different textures and projection mode and like UV tiles to create really cool looking things. And last but not the least, I also added a 2D layer renderer, which lets you place your 2D components directly inside the 3D scene. So let me show you how it works. So all you need to do is right click, go to node, and add a card controller. And on the top, you see a face property, and you can add a HUD element. And as you can see, the element is here, but we have to center it. So you need to reset the position. So if you play that, that'll bring your 2D component in the center. So you can see it's animating. You can also change the position of it in whatever direction you want. You can reduce the opacity, you can change the size. So let's say we scale it down. So yeah, like, so if you have used After Effects, you can turn a 2D element into a 2.5D element. It's kind of like the same thing. So you can basically create some really cool stuff with this. Before we wrap up, I just want to leave you with a few quick notes. This demo is intended for use with the early access build of Rive. It won't work in the marketplace preview or regular playback. To use it, remix the file and open it in early access build. Large 3D models may not import or render correctly in the early access build due to the current limitations. For the best results, try to keep individual 3D assets files around 50 MB or below. If a model doesn't work, try reducing its size or ask AI agent to optimize or fix any rendering issues. And last but not the least, GPU canvas and 3D workflows are still in development, so you may encounter unexpected behavior or compatibility issues. So that brings us to the end of this tutorial. I hope it gave you a good understanding of how to create 3D scripts and shaders in Rive. Be sure to check the description to download the scripts I created. I can't wait to see what you build with them, so be sure to share your creations with us. Thanks for watching, and I'll see you in the next one.